Hi, good morning. This is my 125th video to be released on the New Year Day of 2021. But before I start the lecture, I would like to share my screen and show my words of appreciation to IIT Kanpur. I was visiting the Department of Mathematics and Statistics of IIT Kanpur from 1st July 2019 till 31st of 2020. It has been wonderfully fruitful period for me academically. I have produced about 120 plus videos. This is the 125th on various topics in mathematics, starting from BSc to MSc level and one or two or even at research level. And I made them freely available on my YouTube channel. And all these 120 odd videos were recorded within a period of 6 months. That's 19th June to 18th December 2020. That's almost 5 per week. That's every one video every working day or weekday. And they have been received very well. You can see them from the comments from my channel. And it has got 80,000 views. And there are already, in the last count, 4,600 subscribers. And during this period, I had also published 3 books. But to be very frank, the manuscripts were more already. Most of them were actually even typeset earlier. The last preparation, like, to prepare for camera ready copy for the publishers and fine tuning various small things. Okay, that was all done during this period. And there is a fourth one which is coming, which will be published within a month or two. That's in collaboration with Professor Santanam, who is a professor in the Department of Mathematics and Statistics, IITK. And during this period, I had also written about 10 expository articles, again, starting from BSc up to research level in mathematics. And there had been one partly research, partly expository article, it's a kind of hybrid article, which is published in Proceedings of Telangana Academy of Sciences. And a research paper is sent for publication that is jointly authored with Professor Josna Prajapat of University of Mumbai. I thank from the bottom of my heart the Department of Mathematics and Statistics, Indian Institute of Technology, Kanpur, for its invitation, hospitality, and a very conducive atmosphere for pursuing the academics. And I thank especially Professors Santanam, Debashish Kundu, Amit Mitra for the invitation and the support. I also like to thank the students who took courses 607A, 624A with me. And I have to thank the students of 624 especially, because they took a reading course with me on differential forms apart from their regular course. The last chapter of the fourth book, okay, deals with this theme, and they went through it with a fine tooth comb. Okay, so they had very careful perusal, and they pointed out the mistakes and typos and also made suggestions for improvement. If the last chapter is highly readable, the credit should go to these students. And I thank you, IIT Kanpur, from the bottom of my heart. Happy New Year to all. Thank you very much. Hi, now let's start our mathematics. We shall prove, you may recall, we used to group actions to prove uh, Sylow's theorems. Okay, that's a very powerful technique. So we wanted to emphasize. But then most often textbook use the so-called induction proof, which also make use of the fact that we had already proved Cauchy's theorem. We proved Cauchy's theorem for a Abelian case, but we actually gave you a more general proof also using group actions again. Okay, so this proof is pretty good in the sense it's very simple and it's also elegant and it's a good favored by algebras because it look okay a little more quicker, right? So let us go through the proof now. So let me share the screen. So let's quickly recall what does Sylow theorem say. Sylow 1 says let G be a group so that P is a prime and assume P power n divides P power k divides the order of the group. It's a finite group. Okay, where k is greater than or equal to 0 is a natural number or 0. Okay, then there exists a subgroup H of G so that order of H equal to P power k. Okay, the proof is by induction. Induction on what? On the number of elements in G. So we are going to start with a very cheating case. Okay, suppose mod G equal to 1, that is number of elements is a trivial group, then the result is true because there is no prime a positive power of the prime which divides order of G, right? Therefore I don't know to prove anything. Therefore what one calls it's clear vacuously true because I cannot find such a P. So by induction hypothesis what we are going to assume, let us assume mod G equal to n. Let's assume that for what you call a strong induction hypothesis, but actually the hypothesis is strong induction, but the conclusion is the same. Assume that for every m less than n, and if mod G equal to m and P power k divides m, then okay, there exists a subgroup H of G so that mod of H equal to P power k. So this is the induction hypothesis. Okay, so we are not simply saying for n minus 1 for every natural number m which is less than n. Okay, I have proved the result. So to start the induction hypothesis, I have to assume starting point at n equal to 1. We had already done that. Is that statement clear? Okay. So what is that we are going to do? Now let G be a group of order n and let P be a prime so that P power k divides n. And we are assuming k is greater than or equal to 1. Okay. Why? Because if k equal to 0, there is nothing to prove. The identity element will do. The identity subgroup will do. Okay. So let us assume that. The key fact here is very elegant use of the so-called class equation. Okay. I hope all of you remember using let G acts on G via conjugation. Okay. The orbits are y of x. Okay. The set of all gx G inverse. Right. And when is the orbit 1? If only if it has only one element, if only if x belong to the center of G. Right. Therefore, we can write G as a disjoint union of center of G and union, okay, of this is another union of let us say y of xi, some I equal to some amount to r, where what are xi, x1, x2, xr are distinct representatives of orbits, that is conjugacy classes, okay, which have more than one element. Is it clear? Yeah, and this is what I call this collection is what I call transversal. If you had attended my earlier videos, you watch them, you would know this word. Okay. Therefore, what do we have? We have mod G, the number of elements in G is going to be number of elements is this plus O of Xi. I equal to 1 to R. Right? Okay. Now, before we go further, let us observe something. You, what is O of Xi? Okay. Let Gi be the stabilizer subgroup. Okay. Stabilizer of Xi. Okay. Then what do you know is number of elements is the index of the Gi. Sometimes you also write this. I don't know which is the standard notation. Anyway, you understand this, right? Number of elements is, we had already seen this earlier. Okay, right. What is the stabilizer means? It's essentially centralizer, right? What is the stabilizer of Xi? Stabilizer of Xi, I'm using group action. If you don't want group action, this G is nothing other than set of element G in G, so that Gxi, G inverse is Xi, which is saying Gxi equal to Xig, that is the centralizer in G of the element Xi. I think this is usually denoted by C of G. Right? Okay. There is a reason why I want to observe. We will come to that later. Now there are two cases. Okay. So what is the idea? I want to use induction. That means I have to somehow produce a subgroup, okay, whose cardinality is less than that of mod G, and therefore by induction hypothesis, something will happen. Okay, this is the basic idea, right? So how do I do that? The first thing is assume, okay, P is a prime divisor, right? P divides, okay, we assume P per K divides mod G and K is greater than or equal to 1. That means P divides mod G, right? Therefore, P should divide on the right side of this equation. And there are one sum mod G, mod Z, center of G, and plus these sums or summands. Okay, so what we want to do is we will assume either P divides this or P does not divide this. These are the two cases. So our case one is going to be this. Okay, P divides the center of G, right? Now P divides the center of G, right? And center of G is a group, subgroup. It's actually a normal subgroup, right? Okay. Therefore, by Cauchy's theorem, okay, there is an A which is a central element, so that order of A equal to P. This is by Cauchy. And notice that here we needed only the Cauchy for abelian group because center of G is abelian group. You understand? So the Cauchy's theorem for abelian groups is again proved by induction in one of my earlier videos. Okay. Anyway, we are going to assume, so I cannot keep going back again and again. Okay. So let us assume this. Is it clear? So this is the easy version of Cauchy. There is also a stronger version we have proved. Anyway, is that all right? Okay. Now remember, let H be the subgroup of generated by A. This is a cyclic subgroup generated by B. This therefore what is the cardinality of this is P. Right? Now notice that H is the subgroup of the center and therefore H is normal in G. Because H is a subgroup of the center. How many of you know this? It's very easy because you take G in G and take X in H, then Gx, G inverse. I have to say whether it is in H. But since X is in the center, Gx, G inverse is G inverse X, that is X. Okay. Therefore, it's normal in G. Right? Since it's normal in G, let's look at the group G mod H. Okay. And remember, G mod H, therefore, this is strictly less than mod G. Because mod G is going to be mod G mod H. This is a group now into mod H. And this is greater than 1 because this is P. It divides P. Right? Cardinality of H is equal to P. Therefore, this must be less than this. Is that clear? Okay. Therefore, now I can apply induction. Okay, so by induction, okay, there exists a subgroup, okay, call it L in G mod H, right? Now notice that this is exactly divides P, therefore P power K minus 1 will divide mod G mod H, okay, because P power K divides this, and therefore P power K must divide this, but this is equal to P, therefore P power K minus 1 divides mod G mod H. Is that clear? Therefore, by induction hypothesis, okay, mod G mod H is less than mod G, and whenever a power of P power R divides mod G mod H, then a subgroup of order P power R exists in this group. Okay, that's our induction hypothesis. You clear? Therefore, I know there is a subgroup L of G mod H, so that mod H is, sorry, mod G mod mod L is P power K minus 1. Okay, pause, review, proceed. So what is the induction hypothesis? Let's go back. Induction hypothesis says, okay, where was it? Yeah. How did I write anywhere? Anyway, yeah. If whenever P power K divides this, then there should exist a subgroup of ordered. Okay, now we know P power K minus 1 divides mod G mod H, therefore there exists a subgroup of that by induction hypothesis. Okay, good. Right? Okay. Now let's look at the map phi, the quotient map G to G mod H. Okay, G going to GH. All right. Okay. Now my L is where? L is a subgroup of G mod H. Right. Now let's look at the set K, which is equal to set of all G in G, so that pi of G is in L. This is same as saying pi inverse of L. Right. I claim this is a subgroup. We claim K is a subgroup of G. Why it's a subgroup of G? This is where you need a lot of basic facts about group theory. If your algebra is good, you will find these are all easy. You don't have to remember anything. But anyway, suppose X and Y belong to this, right? I want to say X times Y belong to K. When does XY belong to K? Pi of XY belong to L. This is if or not if. This is a group homomorphism. This is pi X into pi Y belong to L. But L is a subgroup. Pi X belong to L. Pi Y belong to L. Therefore, this similarly inverse. X belong to K implies X inverse belong to K. Yeah, because I have to check pi of X inverse belong to L. But pi of X inverse, because of group homomorphism, pi of X inverse of L. But I know since X belong to K, pi X belong to L. And L is a subgroup. Therefore, this is also true. Therefore, this is a subgroup. Okay. Next, let us look at how many elements are there in K. That's again easy. Okay. Let us restrict our pi to K. Okay. Then to L. Okay. Remember, pi maps K onto L. Yeah, because everything has to be, you start with any G in K, pi of G has to be in L. Therefore, right? And similarly, I am looking at every element which is going to be there. Okay. So this is on to. Now, what is the kernel of this? See, now pi is a group homomorphism. Therefore, by restricted to K, it will also be a group homomorphism. I want to know what is the kernel of pi. What is kernel of pi? Kernel of pi is set of all G in K, so that pi of G must be the identity element of L. But what is the identity element of L? Remember, L is a subgroup of G mod H. Therefore, it is E times R H. But what is pi of G? It is GH. So you are looking for a G so that GH equal to H. So when does this happen? If only if G is in H. Therefore, kernel of this is precisely H. Is it clear? Therefore, now pi is a map of K onto L, and with the kernel equal to H. Remember, H is a subgroup of K. Do you see that why? Yeah, because every identity element, you start with any element x in H, pi of x will be the identity coset xh. You understand? Therefore, H is a subgroup of this. Is that clear to all? Okay. So I have proved this on to with the kernel this. Therefore, my first fundamental theorem of homomorphism, I know K mod the kernel pi is isomorphic to L, that is K mod H is isomorphic to L. Therefore, what should be the size of K? It should be into this H. Yeah. And what is this? This order is P. This order is Pk minus 1. Therefore, order of K is Pk. So we have proved the existence of a subgroup of order P power K. But did you notice something very interesting? Our subgroup H, which you found P power K minus 1, it's actually going to be normal subgroup of K. Okay. You start with, okay, in this, you start with an L, which is a order P power K minus 1, right? You understood? And its inverse image pi inverse L is a subgroup of our kind, and my H is going to sit as a normal subgroup of this. Okay. It's just an aside remark that's not needed for the proof. Okay. Please pause, review, proceed. So we have proved the case when P divides order of mod G. This is over. Next case 2. P does not divide order of the center. Okay. Now let's look at the class equation again. Mod G is equal to mod center of G plus summation mod O of Xi 1 to R. Right? So P divides this, and you say P does not divide this. So what is the conclusion? Therefore, there exists an I so that P does not divide O of Xi. Do you follow that? Modulus O of Xi. Because if it divides all of them, then mod G minus this is divisible by P, but that's equal to center of G. Yeah? Therefore, there is an I. Okay? Right. Now let's look at the corresponding stabilizer subgroup Gi. This is the stabilizer or the centralizer, right? Centralizer of G in Xi. Okay, this is nothing other than this. We have seen it. Okay, I want to know what is the order of Gi. Okay, notice that we know that mod G equal to mod Gi into mod X, order of Xi. Yeah, this is the orbit stabilizer theorem with respect to group action. But anyway, in the general case also, you know that. Okay, if you derived class equation in any other fashion, you would again seen this because that's a crucial part of the proof. Anyway, right? Okay, now you see that P does not even divide this, right? Whereas P power K divides this. You understand? Okay, therefore you conclude P power K must divide mod Gi. Do you accept it? Yeah, P, not even a single power of P divides. Therefore, but the left side is divisible by P power K. Therefore, the right side must also be divisible by P power K. And this factor is not at all divisible by even a single power of P. Therefore, this fellow must be divisible by P power K. Good? Okay. Now, what do I know about order of Gi? I claim it's less than order of G. Why? Because remember, our orbits, this x1, x2, xn are such that their orbits have more than one element. You understand that? Therefore, this fellow is greater than or equal to 2. You understand that? Therefore, mod Gi is strictly less than mod G. Now, what do you have? We are reduced to induction hypothesis because P power K divides mod Gi and mod Gi is less than mod G. Therefore, by induction hypothesis, there is a subgroup H of Gi so that mod H equal to P power K. Right? You see, the proof is extremely simple. If your algebra is extremely good, okay, many of the detail which I gave is unnecessary for you. Okay. the proof would have been much faster, and you would have completed. So we'll again come back after some time, because there will be kind of a rest period for the next few weeks, since I am shifting from IIT Kanpur to Hyderabad. I have to get internet connectivity, etc., and various other small things which I have to do, household work. So after that, I will again come back, and probably I will give two lectures on a variety of examples how to use Sylow's theorem. Okay, if you had mastered most of the problems, you will be able to solve easily. Okay, till then. Okay, I wish you all a very, very happy new year. Enjoy, stay safe. We'll meet again in possibly a healthy 2021. Okay, bye.